Hey guys, welcome to my channel. I solve LeetCode 75 list using Go programming. So let's look at today's problem, can place flowers. So let's look at the question. You have a long flower bed in which some of the plots are planted and some are not. However, flowers cannot be planted in adjacent plots. This is important. Given an array flower bed containing zeros and ones, where 0 means empty, 1 means not empty, and an integer n, return true if n new flowers can be planted in flower bed without violating the non-adjacent rule, and false otherwise. So let's basically look at one example. The first example. So this is the flower bed and we need to place one flower. So can we do it? And it should be non-adjacent. That's the rule. So what if I make place one here? So this way nothing is adjacent, so it meets the condition, so output is true. Let's take another example. So I need to place two flowers in this flower bed. So here if I place one here, and then I can't place anything else anywhere else, so for this it will be false. So that's basically the question. So if you have understood it intuitively, let's look at how we can solve this. So basically, if you're given a array like this, and the way I can think of solving this problem is using greedy solution. So what I would do is I would have a pointer I will go here. Is it possible to plant a flower here? So here there is already a flower, so we need to only look at empty spots. So first empty spot, can I plot here? I'll look at left and right because those are the adjacent positions. Left, it's already planted, so I can't plant here. I'll come here, this position, can I plot here? I can, right? Because left and right adjacent are both 0. So here I can plot a flower, sorry. I'll plot here, and then n is already 0 because I already plotted one of the flowers, so I can just return true. Similarly, let's take this example. I is in the first position, it's already a flower is there. I go to second position, left side already a flower is there. I can't plant here. I go here, left also no flower, right also no flower. I can plant here one, and n becomes 1, and then I come here. This is the only empty position, but both the places there is flower, so there is no way I'll be able to plot here. I hope you guys understood the logic. I'm checking left and right because they've told that no adjacent flower rule. So basically left side and the right side immediately there should be no flowers. So the only way I can place a flower is if consecutively I find like 3 zeros. That's the only way I can plant a flower. So as I mentioned, we will be solving it greedily as the method I explained. So let's see how I can do this. First is initializations if I have any, and then is the greedy logic, and then it will just be return statements. So initialization, I think the only thing is I need to capture the length of the flower bed. So len of flower bed, and initialization should be done using this. And then let's go to the greedy logic. So let's have a for loop which goes from I length I plus plus, and then so left Okay, let's call it left. So as I mentioned, okay, even before that I need to do this check only if the current bed is empty. So flower bed of I should be 0 first of all, only then I can check. So left, what should be the case? Flower bed of I minus 1 should be 0. Flower bed of I minus 1 should be 0. But there is one edge case here. Since we are starting with 0, I minus 1 can be minus 1 also. So we should handle that case. So basically, if I is equal to 0, if I is equal to 0, or if I minus 1 is equal to 0, then basically left is true. I hope you understood the condition. Let's say I'm at this position, I'm checking if this is 0 or not, or else if I am at this position I can immediately return true because there is nothing to the left. That's what I mean. And then similarly check for right. I is equal to n minus 1. If we are at the last position, we don't have to check right because nothing exists. Or flower of I plus 1 has to be 0. We are checking that. And if both left and right are true, what should we do in this case? In this case, we need to plant the flower. Flower of I, make it 1, decrement n. And if at any point n becomes 0, we can just return true. This is because I'm just returning true early. If we already are able to place flower, we don't have to like keep doing the loop. And then once you come here, one common mistake is you might directly just think, yeah, let's just do false. But this is wrong. That is because even after you complete looping, we might not have like completed all ends. Basically, we are returning early if we are able to like plant all the flowers. But even after we complete the entire loop, there might be a possibility that we have not planted all the flowers. So if we have not planted all the flowers, n will basically be greater than 0. So let's just return true only if n is lesser than or equal to 0. So which essentially means if n is greater than 0, it returns false, otherwise it's just returning true. So this is the logic. Let's run runtime error, index out of range. Where what is the issue here? Flower for I is equal to 0, I less than length I plus plus. If flower bed of I is 0, left I is equal to 0, or flower bed of I minus 1 is equal to 0. Right is equal to I is equal to oh sorry, it's not n minus 1, it's length minus 1, because length is the length of the flower bed. I hope it fixes the problem. Yeah, 100% runtime. Let's also analyze the time complexity here. So essentially we are just going through one full loop, so time complexity will just be like fn. And space, are we using any extra space? No, that's good. We just have like O of 1 space. We are not making use of any extra space. So that's it for today's guys. Thank you so much for watching my video. Looking forward to meeting you in the next tutorial.